Okay, starting today, you can skip the warm-up. You have the general idea of what's happening to these, right? All of this x moving left, moving up. So first, when you're graphing exponential functions, you are going to graph a times b to the power of x. B to the power of x is going to be your parent function. So we move on. 4 to the power of x is your parent function. We have minus 2 plus 1. So you're going to the right 2 and up 1, giving you a domain and range. If I'm going too fast, you're going to have to pause it. Here, 1/2 x to the power of x is our new parent function. So 0 at 1, then we're going to the right 1 and up 3, giving you a domain and range and an asymptote. Alright, next one. It says that we have to graph a times b to the power of x. So b to the power of x is 0 at 1 and 1 at 3. But because of that 10, we have to multiply all of the y's by 10 and then graph it, giving us a new domain and range. And same thing for this one then. The first thing we are going to graph is these points, -2 and -0.5, giving you this domain and range. Alright. I know I'm flying through this, I just don't feel that great, guys, so I'm going to need you to pause it and write down what you need to. The notes are also posted online. Okay, exponential models. You are going to enter this into your calculator in list 1 and in list 2. So, you have your calculator. If mine would load, you'll enter all that. You'll end up going to stat, enter. After you've entered it, you stat calc, scroll down, exponential, enter, 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 go. Okay? That will give you this equation. We know we're looking for it at 185, so that's your y2, y1. You enter those. And we had 196.657. All the power of x, graph, zoom, you have to do the fit, second trace, intersect, first curve, second curve, enter, 2.697. I don't know why I wrote 5. That's just how it was. Change your 0.65 into seconds, 2 minutes and 42 seconds. All right, these ones. We're looking, we have an A, we have a positive interest, and we have a time of 5 years. Using the equation we learned yesterday, you get 2,000 times 1.07 to the power of 5. Now we're looking at what happens when we compound interest. So we have this formula, A equals P times in parentheses 1 plus R over N to the power of N times T. What that N is going to be what you're compounding by. So we're compounding monthly. So our N becomes a 12. And so typing that in your calculator, you end up with a 2,835.25. So that's what it'll be monthly. You figure out what is it going to be weekly. 52 weeks in a year, daily, 365 days in a year. You take a minute, you figure that out, what you think it's going to be. Weekly, we end up with an equation like this. This is your monthly, your daily equation. And this is what it would look like. So what would it look like if we compounded continuously? We would have those infinities in there, and it just doesn't work. You can't type infinity into your calculator. So we have this new equation because what it says is when we have something going to infinity and it's in this form of an equation, it's going to be approximately to the power of e. So e is about 2.7. So compounding continuously gives us a is equal to p, being your principal, your initial amount, interest rate in a decimal, time in years. So we would go back. We would type this in. 2,000 times second divide is your e, 0.07 times 5. 2,838.14 and 14 cents is what that ends up being. So we do it again for this one. A is equal to 500 e to the power of 0.0525 times 40. When you type that into your calculator, you get $4,083.08. Fabulous. All right, typing these in your calculator. You just are taking that second e to the power of 20. And you're gonna round. Oh, why did I type in 20? Wow, my bad. To the power of 3 would have been the right way to do that. And you get 20. That's why I'm typing in 20. Okay, so you take a minute and you do that for the next 5. This is the only tricky one because you're getting an answer like that, which is really 0.000454, which is really 0, pretty much. Alright, using a graph. We're going to type in our graph. Y is equal to e to the power of x. Ooh, my bad. To the power of x. Graph it. Zoom standard is what I wanted. Zoom standard. Alright, second, calculate a value when x is equal to. So when e to the power of x is 2, we are looking for when x is equal to 2. So x is equal to 2, 7.389. And you will do that for the next two. For when x is equal to 2 over 7, and when x is equal to negative 0.5. Using a table. Second, table. When they go by ones, that's fine. We look for the 5, we get 148. Fabulous. The problem with this table is that we need to change it. So you press plus. I want my table to go by 0.1 for this next one. And we see negative 0.2 is 8.19. Okay, pressing plus. Now we want it to go by 1/3. So 1/3 is 1.396. Right. Lastly, we have to graph. Graph like you normally would. Find your parent function. E to the power of 0, 1. E to the power of 1, 2.7. Graph those dots first, then see what's happening. We are moving down 4. So, then find your domain, range, and asymptotes. Here, we have a negative on the outside. Flipping over the x-axis, we multiply our y's by negative 1. Negative 1. So, negative 1, negative 2.7. Find your domain and range. Then our last one. I rewrote this because I think it's easier to see that now, firstly, we have to flip over that x-axis. So we have our parent function flip into the x-axis, just like we did up here. And we have to move everything up 4. What's that plus 4? Finding our domain and range. If you have questions, write them down for Monday. I will be back then, hopefully. Otherwise, work on your homework and have a really great day.